Hello again, this is Dr. Rafeeq. Today I'll talk about generics again. It's as we talked about generic methods in the previous video. In this video, I'll talk about generic classes. Before I get started, let me share with you this problem. So here, I'll start by declaring a new object. Let's say D, which is an object of date class. So we need to import Java first. Now we have D as a date, and the date is a comparable here to compare the dates. And now let me try this. I want to compare the D with another object, and because the D is a comparable, then I can use compare to, as you know. So here, instead of comparing D to another date, let's say by mistake we did comparing it with a string. Look at this. So here I'm trying to compare a date with something as read, which is a string, two different data types. Here, the compiler didn't recognize any problem and nothing wrong here based on this compiler. So let's try to run this code. Look at this. I have an exception. There is a problem. This problem have been displayed in runtime, and this we don't want to see this problem at running time. So this is one of the problems that have been postponed to the time of after compiling the project. Then after running it, I'll see this problem. So it's better to do this to specify exactly what is the comparable will be. We have to compare the D to any object of type date as well. So look at this here. The compiler now is helping you, is telling you that there is something wrong. So we move the problem from running time to this time. You see that? So instead of facing this problem in the running time, and this is a big problem, now we are facing this in even before the compilation time, and the compiler is helping you to point to this problem and telling you you cannot compare a date to a string. You see this? So this is what we want to say. So here comparable is an interface, comparable is a generic interface, and here you can either set the data type of the comparable and restrict the data, restrict the comparison here, or just leave it open. When you leave it open, then this will cause a problem at running time, and we don't want to see this, as you can see. But here it's pointing to that. So before execution or executing the program, sorry, or the project, I can see the underline here, the red lines, and I can fix this before I publish my project or even before I execute it. Okay, so this is one of the benefits of using um, generics, and to specify exactly what is the problem here. So as we mentioned that that this situation here is not safe. It's unsafe to use this format. This is known as row type. So row type is not or unsafe. So it's better to do this and to specify the data type here and to get rid of this problem. So remember, row type is unsafe, and this is a better way to help you to recognize the problem ahead of time. Now, now let's do our own class and to make it as a generic one. So if you are familiar with stacks, so stack is a data structure that has a property of first item in will be last out. So first in, last out. This is one of the features of a stack. So we are going to build a new class, and this class will be called as a stack. This stack will do the job for us to save some element and to retrieve those elements. With a stack, as you know, we have some common operations, such an example pop to retrieve and delete the element at the top of the stack. Push to insert means to insert an element into a stack. Peek to retrieve an element at the top without removing it. And we will add some other methods, such an example the size of the stack and the status of the stack if it is empty or not. So let's start doing a regular stack, and then we'll go from there. So here I'll start a new class, and here I will say stack class, and now we can do this. So if we keep the stack as this stack will be a concrete class. This class will be good for just one data type. So we can do like this: array list, and here, sorry, and here I'll keep it like this as a list and equals to new array list. So again, we need this. Sorry, here. Array list equal. So look at this. Here we have array list named list, but as you remember, this is a row type. So I didn't specify the data type that we are going to save in this array. So this is unsafe. So it's better to make it like this and to specify the data type. So here I am saying this list is of type integer, and we can tell, or the compiler will help us if we are inserting something unexpected or something is not a type of integer, then the compiler will notify us. In row type, if we use the row type um, or an array list without declaring the data type, then this will be a problem in the future when you execute the program. So now let's move on, and let's do the first method, which is the size of the array list. or here in this case the size of the stack. So here I'm going to return the list dot size, and this is one of the methods. So we'll do another method, another operation. Here I'll say it's integer. Let's unify all of these, and let's say that we have integers, and here integer, then peak, and this method is going to retrieve the element at the top without removing it. So all what we do is return and then list dot get, and here is the last element at the top. So here is the peak, and we'll do the same, public integer. Now I'm doing just a regular stack, and this will be a concrete class that can just process one kind of data. It's just one data type. So here I'll do this list dot get, and here get the size, just to save the element before we delete it. Remove, now to remove that object, it's at the top, so we are using the get size method that we just created, and then removing it after saving it. Now I can return d, and here is the pub. One more thing, public void push to insert some elements into the stack, and here to do so we are going to add that element to the list. And finally we can do a method named is empty to check whether the stack is full or not. So here return list dot is empty. Okay, so that's good. And now I don't want this one, it's not necessary, we didn't use it. And this is the stack, and this is the array to represent the stack, array list, get size, peak, pop, push, and is empty. Okay, now let's switch back to the main, and let's declare an object of this stack. Here st1 dot push to add new element, st1 dot push, here 5 st1 dot push, and something like this. If we want to retrieve some elements, then we can say st1 dot pop, retrieving it and deleting it. Okay, so this is the thing. Let's run this one, and we can see that those are the element that we pushed. So the first element is 332, and the last element is 5, so 6, sorry. So 6 will be served first based on what we've done. So 6 is at the top, and this is the one that will be retrieved first. If we do the same thing here, repeating this statement one more time, we can see the next element. So the 5 will be at the top. This one will be retrieved first, 5 second, and 332 will be the last one. Okay, so for sure we can do a loop counter or loop or a counter to fix or to walk through the element of the stack. Now, imagine that we want to do another class, okay? But this time we want to do this here, new stack, and now I want to save some data here, okay? So when I run this code, look at this, I have an error because this stack is prepared to accept and process just one data type, which is an integer as we specified. But here we are pushing a new element of type string. So we declared another stack. This stack is, I'm sorry, this stack is adding some unacceptable item, and this is a problem. So imagine we want to um, use the same stack, the same data structure to save different data types. So this will not gonna work here in this scenario. We need to improve our work to be good for different data types. So now to make a generic class, a generic stack, we need to do the following steps. First, let's go back to our stack. So here is the class, and now I'll convert this one to a generic one. So look at this. I am starting to do so. So this is the data type will be used from now and on. I will not specify any data type. It will be generic. It will be E. E will be replaced by a data type later on. So I'll replace, sorry, I'll keep this one. And for sure, we can do integer if you want here, or even class integer. So, but here we need to do this one to make it a generic method, and here a generic one, here generic, and here a generic one, and we are done. We kept this one as int integer because the size all the time is of type integer, and this doesn't matter. So we'll save our work, and then we'll switch back to the main. Look at this, it's fixed, it's good, it's done now. So I can do more here to push some new elements. Now let's change some data here, red color, whatever. So now if I want to um, retrieve some element st2.pop, then we'll see the output. Run, no errors, and this is the block at the top of the stack. Okay, stack. So if we do the pop again, then the white will be next, red will be next, and finally the color will be the last element to be retrieved. Okay, so this is the generic, and we converted this class to a generic one. And here we didn't specify. Actually, we didn't specify the data type. The data type is generic. It's not specified yet. and here because we are working on just one and only one data type, so we selected one element here, one variable. But if you have, let's say, two data types in your stack, I mean, maybe you have more than one um variable that has more than one data type, then you can just add one more thing here. And let's say that I have um, another variable like um, um, color, number, whatever. So look at this one. So here we have two uh, two things, two data types, E and T. The array will be of type E. The color number will be of type T. So maybe both of them will be integers, or one of them integer and the other is double or string or whatever. And this how to do more than one data type in Java. So this is all for this lecture. I hope you learned something new. Thank you and see you in next videos.